We are going to take notes today on this sheet, but we are going to ignore the top half. Don't cross it off. We may come back to this a different day, but for now, we're going to focus on parallel and perpendicular lines. We are going to come back to the sheet in a minute, but for now, I want you to just listen to an overview on parallel and perpendicular lines, and then we'll fill this in together. So parallel lines are lines that never intersect. And perpendicular lines are lines that intersect at 90 degrees. So we should be seeing right here that they're going to connect at a 90 degree or a right angle. What information does this give about slope? So if you look at the graphs down here, I have a parallel set of lines and I have a perpendicular set of lines. Parallel lines, you can see that they have the same rise over run, up 2 over 1 in this case. But if they're never going to intersect, they have to run with the same slope. So parallel lines are always going to have the same slope. Looking at perpendicular lines, I use the red line is the same, it's just up 2 over 1. So the slope for the red line is 2 over 1. But for the purple line, we are going down 1, so negative 1 over 2 is the slope for this one. And all perpendicular lines, so if they have to make this like box right here and hit at 90 degrees like they do for perpendicular, their slopes are what we call opposite and reciprocal. Opposite means you are going to switch the sign. And the reciprocal means you flip the fraction. So when we're looking at one of the slopes is 2 over 1, and it's positive, the perpendicular slope would be negative, and instead of being 2 over 1, it's 1 over 2. Another way that you can check this is the product of the two slopes. If I take 2 over 1 and I multiply that by negative 1 over 2, the product of perpendicular slopes is always going to be negative 1, so that's a check for you. Now we're going to fill in our notes together from what we just watched, and you're going to focus on the bottom half. So parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. Sometimes we say negative instead of opposite, but it means the same thing. And what that is telling us is that it is the opposite means we are going to switch the sign of our ratio, and reciprocal means we're going to flip the fraction. So make sure you have that on your notes, both parts. So looking at these two examples right here, the thing that we need, we're being asked, oh, I didn't mention this. So 2 lines like this is a shorthand way of saying parallel, and this upside down T is a shorthand way of saying perpendicular. So when I'm looking at this, I'm given this equation, and the slope in this equation is 3, and I'm going to write that as 3 over 1 because I want it to be as a ratio or a fraction. Then I'm being asked for 2 things. I'm asked for the slope of the line parallel, and I'm asked for the slope of a line that would be perpendicular. That's what those little notations mean. So if it's a parallel line, we know that it's going to have the same slope, so it's just going to be 3 over 1. If it's perpendicular, it needs to be opposite and reciprocal. So it was positive, so now it is going to be negative, and it was 3 over 1, now it's going to be 1 over 3. So a perpendicular slope would be negative 1/3 to a line that has a slope of 3. So let's take a look at the next example here. Our slope, again, coefficient of x, so it is m is equal to negative 1/2. Parallel lines will have the same slope, so it's going to be negative 1/2. Perpendicular lines are going to have opposite, so it was negative, so now it's going to be positive. And it was 1/2, and so to flip that fraction, it's going to be 2 over 1. So positive 2 over 1 would be perpendicular. You can always check, because if you multiply these two numbers together, you can use your calculator, you should get a product of -1. That would let you know you did it correctly. Flip to the back side, we're going to change the directions and we're going to only focus on the top two steps, finding the slope and writing the equation in point-slope form. So for now, we are not going to write it in slope-intercept form. We're going to just focus on these two. Let me zoom in. Let's write our reminders at the top of our page that a parallel slope is the same and that a slope that's perpendicular is going to be opposite and reciprocal. And you might want to even add that opposite means switch the sign and reciprocal means flip the fraction. Example 13 just asks for an equation that passes through these 2 points. We're going to put that in point-slope form. So this is a review of what we did last class period. We start by finding the slope, which I always make a little mini table for. So from 4 to 10 is increasing by 6. From 3 to 5 is increasing by 2. So my slope is 6 over 2, which reduces to 3 over 1. You could even write it as 3. For my equation, I can pick either. I'm going to pick the first one. So that is going to be 3 times x minus 3 plus 4, because inside the brackets should be opposite of what you have in your point. So these are opposites, and outside the brackets or the parentheses are the same. It would be accurate to use the other point. That would be correct, that you could have y equals 3 and then x minus 5 and then plus 10, but you only need one equation. So pause here and do example 14. Do a quick check. You should have got your slope to be 1/2, and either one of these equations is correct. You did not have to put it in slope-intercept form, and you only need one equation. I don't care which it is. For example 15, we're talking about a line that goes through the point 0, -5 and is parallel to this equation right here. So the only thing we care about in this equation is the slope. So the slope, remember, is the coefficient of x. So I look in front of x. This right here is my slope, and my slope parallel is going to be exactly the same. So now I just need to use this point with this slope using point-slope form. So y equals my slope, -9, x minus 0 in my parentheses, and then minus 5. So remember, doesn't really matter for opposite when you're talking about 0, because 0 doesn't have an opposite, but -5 is the same out here. And so you could simplify x minus 0 is just x, but it's fine to leave it like this for this example. So pause here and you do example 16. Quick check of example 16. So you hopefully saw the slope was -1. Because it's parallel, it needs to be the same. And we're going through the point 4, 4. So y equals -1, x minus 4, because I have a plus 4 here, and these should be opposites. Inside the parentheses are opposites, and then outside is the same, so it stays plus 4. So now we'll look at 17 and 18. So for 17, we want an equation that goes through the point -2, 4, and is perpendicular to this equation. And again, perpendicular is talking about slope, so we're only looking at the coefficient of x. That's opposite and reciprocal slope. So it was negative, so now it's going to be positive, and it was 1/2, so now it's going to be 2 over 1. So a positive 2 over 1 slope is the perpendicular slope, opposite and reciprocal. And it has to go through this point. We're going to use point slope form again. Y equals 2. You could put 2 over 1, that's fine. X, and then instead of a -2, like is in my point right here, we're going to have a +2 and then +4 on the outside. So opposites here, so -2, +2, +4, and +4. Pause here and do the last example. Quick check here. Again, we're talking about perpendicular, so it's going to be opposite reciprocal. So we look at our slope, coefficient of x, 3/4. Perpendicular slope is going to be negative because this is positive, and it's going to be 4/3 because this was 3/4, and we have to flip the fraction. Using this point, it's going to be y equals negative 4/3 times x minus 6, plus 6 in my point, minus 6 inside my parentheses, minus 5 here, same minus 5 here.